Here are the free responses from the practice test you took. I'm going to kind of outline the thought process for each part of the question as I see it, and then I will show some more of the details after that. So we have fish entering the lake and leaving the lake. So this is my rate in, and this is my rate out. And we also, they're saying that we are measuring in fish per hour. T is measured in number of hours since midnight. How many fish enter the lake? From 3 to 5. So how many fish enter? That means we're using the rate in. And since we have the rate that they enter and we want the amount that enter, that's going to bring us back to an integral. So that's just an integral from 0 to 5 of E of t. And from there, it's just calculator work. Average number of fish that leave the lake per hour. This is average value of the function that has to do with the amount of fish that leave the lake per hour. So the average value of my rate out, L of t. For part C, we're being asked what time is the greatest number of fish at the lake. So that is asking for a maximum amount of fish in the lake. And then part D is asking, is the rate of change increasing or decreasing at t equals 5? So this is a question, if we're asking whether a rate is increasing or decreasing, then that means we're being asked about the second derivative. We're being asked about the rate of change of these rate functions. So basically, we're going to be asked about, that's going to be a question about E prime versus L prime. And which one is outweighing the other. What's the rate of change of the rate in? What's the rate of change of the rate out? And we compare those two. So that's the overall process. So here's how the details look. There's your rate in, there's your rate out. How many enter? So we just do the integral from 0 to 5. It asks to round to the nearest whole number, so I did. Part B, average value, 1 over b minus a times the integral from a to b. Fish per hour, since that's what L is looking at. We are going to look at the analysis of going down to part C. I want a maximum, which means I want to know when the rates change from being positive to negative, and that happens here in my graph. So the amount of fish would be the integral from 0 to x of the rates. So if I have the rates, I want to get back to amounts, I use integral. And the amount would be the integral of the rate in minus the integral of the rate out. So I already know that at 0, there are no fish. And I could plug in, basically plug into my calculator to get out what the values are at that 6.2 and at 8. And which one's the biggest? It's the one that's 135. That is my maximum amount of fish in the lake. And then part D, like I mentioned, this is a question about the second derivative. And that's E prime of t minus L prime of t, which is negative. So the rate of change of the number of fish is decreasing at t equals 5. Question number 2. Again, I'm going to give an outline and then I'm going to give the details. For part A, if it asks about a time t where the derivative equals a certain amount, then that should be a clue that this is a mean value theorem question. So remember, for mean value theorem, you want to say that the function is continuous and differentiable, and then you want to do f of b minus f of a over b minus a. And hopefully what you get is that f of b minus f of a over b minus a is the value that it says it should be, which in this case is 0. So that's what you're going to see me do in part A. It's saying that the derivative equals the average rate of change somewhere in the interval. Part B is asking you to do a trapezoidal sum. So trapezoidal sum, remember that area of a trapezoid is h over 2 times base 1 plus base 2. And your trapezoids are going to end up looking something like this. Here's my bases, and then my height is my distance along the x-axis. And each of them are going to be different heights in my trapezoid. So I can't take a common factor out in this case. I have to treat each as an individual trapezoid. In part C, it gives a new function q. So now we're not worried about particle p at all. We're just focused in on this function. So start by putting it in the calculator. Find the time when the velocity is at least 60 miles an hour. That is just, this part is just a calculator. Put this in y1 equals this, and put y2 equaling 60, and figure out where they intersect. And then I want the distance traveled over that time. So the total distance traveled is going to be the integral from from those two intervals of the absolute value of velocity. Because that's what total distance traveled is. So figure out what the interval is that they're looking for. That's calculator work. And then total distance traveled. Distance between P and Q. So P, we approximated where P was at t equals 2.8. We did that up here. So this is my trapezoidal rule answer. And then for Q, at 0 we start at negative 90, so negative 90 should be my starting position. And then I want to add in the integral from 0 to 2.8 of velocity at Q. And to figure out the distance between the two, here's the position of P, here's the position of Q, so we're going to subtract them. That's my outline for that question. So that doesn't leave your head, let me jump down to part D and show you how that looks. Just so that you see. Because that's the most difficult part of the question. First off, position of P we got from the trapezoidal rule. That's what the trapezoidal rule should be. I'll show that in just a second. Position starts at negative 90, so we have negative 90 plus the integral, which winds up being that distance. So figure out the distance between those two by subtracting them. All right, let me jump back up. Part A. Part A, here's your f of b minus f of a over b minus a, and what do you know? It's 0. So therefore, the mean value theorem says that there must be a time in the interval where the derivative is 0. Part B, here's your trapezoidal rule. H over 2 times base 1 plus base 2. I'm going to do that across the board for each individual trapezoid, each of the 3 trapezoids that we're looking for. In part C, the calculator work says that we're above 60 from here to here. So that is my bounds for the integral of the absolute value of velocity. So that's your work on question 2. Question 3. Oh, this was a tough one. So we have the graph. Remember, this is the graph of f. So that means that this is the graph of let's see, continuous function f. So since we are looking at an integral here means that we're talking about areas from -6 out to these possibilities. And in this case, from -2 out to 5. So let me go ahead and show how that integral works out from -2 to 5. Integral from -2 to 5 of f of x dx. Well, that's going to be a bunch of area formulas. So first off, we have this little triangle right here, which is going to count as positive. That's going to be 1/2 base times height. And my base here is 1. My height here is also 1. So that's going to equal 1/2. So this is a positive 1/2. Then I have this next triangle down here. That is 1/2 base times height, but this time my base is 3/2. My base is 3/2, and my height is still 1. So that's going to be 3 over 4 is going to be my area here. But that 3 over 4, since it's below, is going to count as negative. So we have a -3/4 area here. Then I've got another triangle going up to 2. This one has a lot going on in it area-wise. Again, 1/2 base times height. My base is still 3/2. And then my height is at 1, 2, 3. So this is going to be a positive 9/4. 9/4, and it counts as positive. And then finally, we want this area right here. Well, if you wind up with circles or semicircles or quarter circles, the easiest way to do areas here is by treating it, is by taking a rectangle, putting a box around it, and then subtracting away the circle part that I don't want. So that's going to be rectangle minus quarter circle. Rectangle minus quarter circle. So the rectangle, the base is 1, 2, 3, and the height is 1, 2, 3. So the rectangle is 9. The quarter circle is going to be a quarter times the area of the circle, which would be, my radius would be 3, so pi times 3 squared. So that's going to be 9 minus 9 pi over 4. So that's the area that you're going to need to do to get the integral from -2 to 5. So that's what part A is asking you to do. Part B is a little bit easier. The integral from 3 to 5, I'll just show real quick. Antiderivative would be 2, antiderivative of f prime would be f, plus antiderivative of 4 is 4x, and we're evaluating this at 5 minus evaluating this at 3. This is why it gives me this point, is to do part B. And then you'll see the work of doing the absolute maximum. So absolute maximum, I want f prime to go from positive to negative, which happens here. And then I want to compare with endpoints. And then part D is really complicated and intimidating looking. But this one, it turns out that you can just plug it in. And it works. Plug in 1 and everything works itself out nicely. Really complicated looking thing, but I can just plug in 1. So that's the building blocks. Let's see how the question actually looks. One more thing to point out here that you'll see. It is asking about the integral from -6 to -2. And the integral from -6 to -2, we're using the fact that the integral from -6 to 5 equals the integral from -6 to -2 plus the integral from -2 to 5. So we're figuring out what this is. We know that already that this is 7. We were given that in the problem. And so we're going to solve for that integral from -6 to -2. So lots of pieces going on here. Let's take a look. So that's a lot of the nitty-gritty details. Now let's look at how this works itself out. So part A, here's me splitting up the integral and figuring out that splitting up those integrals, I should get 7. Here's the integral from -5 to 2. So this is me working out all the different areas and combining them together. So that's this little triangle, this little triangle, this little triangle, and then this rectangle minus the quarter circle. And totaling all that up, I get 11 minus 9 pi over 4. Remember that that is my integral from -2 to 5. So to actually get my answer and to solve for the thing that we actually want, then we need to plug that in here and solve. So again, lots going on there. Part B, I already covered the antiderivative here. Plug in 5 minus plug in 3. Good news, at 5, f is 0. Plus 4 times 5. And then minus 2 times, well, f of 3 was given to us plus 4 times 3. So I work all that out, and I get 2 plus 2 squared root of 5. G has a maximum when G prime, which is f, is 0 and changes from positive to negative. As I pointed out, that happens if I look up here at -1. -1 is when this function changes from positive to negative. So we take and we compare our endpoints, which are actually, now that we've gotten down to part C, this gets easier, actually. Because -1 is the only place I need to look. And I already know the area. That's the area, that little triangle there, which was the 1/2. Then, since it was the integral from -2 to x, then when I plug in -2, I get the integral from -2 to -2, which is 0. And then g of 5 I already did in part A. So which one is the biggest? Well, it's going to be the endpoint. So this is why it's important to test out your endpoints and compare it to my other candidates for the maximum. Sometimes it's the endpoint. And then part D, we just plug in 1. So the only real calculus in that part of the problem is knowing that f prime of 1 is 2, because that is my slope of that graph at 1. Lots going on in that question. We're going to cover graph questions later this week, so if that's still not making sense, stick around to when we cover the graph question and then try coming back to this problem and this explanation to see if it's making more sense to you. Number 4. All right, I won't talk through too much of this. Part A is your related rates question. Find the rate of change of the volume. It's giving you dH dt. Because it's telling me that the height is 4, so dH dt, plug in 4 for h. So that's what dH dt is, and it's asking you to find dV dt. And the good news is that in this volume formula, R is constant. And R always equals 1. Since my diameter is 2, the radius is 1. In cones, my radius, I would need to figure out a dr dt and work with the product rule. I don't need to be that fancy here. So really, this is pi times 1 squared h. Height changes as I move up and down here, but my radius doesn't. So really, v equals pi times h, which means that dv dt equals pi times dH dt. So now I have dH dt, solve for dV dt. Part B. Is the rate of change increasing or decreasing? So here is that question again. Rate of change increasing or decreasing means that I am asking a question about the second derivative. So we need to figure out the second derivative there and then answer whether we're increasing or decreasing. Then for part C, here's that initial condition, and it's asking you to use separation of variables. Use separation of variables. So here's dH dt. And so your first step should be to separate out the variables. Move the dt over to the right, move the square root of h over onto the left side. Integral, get your plus c, plug in your points, solve for c. I'll show that in just a second. So we're finding dV dt. I did do this out the long way and using that dr dt was 0. So this entire piece went away. But either way, you should figure out that dH dt is -2/10, which is -1/5. And so dV dt is going to be -pi/5 feet cubed per second are my units there. Then it's asking about when h is 3, so I went ahead and calculated out dH dt. negative root 3 over 10. Then my second derivative, derivative of negative 1/10 square root of h. Real quick, if we have negative 1/10 square root of h, then my derivative there is going to be negative 1/10 times my derivative square root of h is 1 over 2 root h. So that's how we wound up with a negative 1 over 20 and a square root on the bottom. So plug in 3 and plug in your dh dt. Luckily, these two things are going to cancel. The square root of 3's are going to cancel. Negative times a negative is a positive. So our second derivative is positive. That means our rate of change is increasing since the second derivative is positive. And then here comes your separation of variables. Here's me separating out the variables. Antiderivatives plus c. I went ahead and solved for c right here. And then went from there to solve for h. So, moving forward to question 5. I'm going to draw a couple pictures here. First off, in part A, find the area of R. That's just going to be top curve minus bottom curve. I know, I should know, that this is my downwards facing parabola. So this is h of x. And then this bottom curve is the one that looks like a cosine wave. Maybe move down a little bit. Right? It would go on to look like that. So my top curve, this is my top curve, this is my bottom curve. So when we do part A, this minus this will be your integral there. Part B, don't overcomplicate it. It gives you the area formula. So just take the integral of that area formula to get the volume of the cross section. Usually, it gives you a shape and you have to come up with the area formula. But this time, it just tells you what the area formula is. So let's just do that integral from 0 to 2. And that's it. Now, finally, the last part there is showing revolving around y equals 6. Y equals 6, 1, 2, 3, 4, 5, 6 is right up here. So that's going to end up being a washer. And so we need to figure out big R and little r. Big R, just as an example, is going to be top curve minus bottom curve. My top curve for big R would be my 6. That's where it starts. That's where my distance starts. And then I want to subtract the bottom curve, which is the cosine function, so g of x. And then I can do the same thing for little r. Top curve is 6. Bottom curve is the parabola, so f of x. So that's the structure of our revolving around y equals 6. Now, here's some details. Look at that drawing. Part A. Top curve minus bottom curve there. I work out these antiderivatives. The trickiest antiderivative here is the 3 cosine. So first off, antiderivative of cosine is sine. Of pi over 2x. But right now, because of the chain rule, I would have a pi over 2 that comes out in front that I don't want. So I need to cancel it out by multiplying by 2 over pi to counteract the pi over 2 happening inside. So that's how I wind up with the 6 over pi happening in here. Rest of the antiderivatives should be more straightforward. And we're through plug in 2 minus plug in 0. And that's what I get. On part B, our antiderivative. Antiderivative of 1 over x plus 3 is natural log of the absolute value of x plus 3. Plug in 2 minus plug in 0. They took natural log of 5 minus natural log of 3 as well. But if you know your properties of logs, we can write that as a single log. Here's my drawing of the washer. Big R, top curve minus bottom curve here. Little r, top curve minus bottom curve here. So that is my integral. Don't forget the pi out in front. It's still from 0 to 2. That's question 5. And finally, question 6. Question 6, I'm going to go ahead and start by saying that I think parts A and B are doable for everybody. You should be getting parts A and B right. C is pretty hard. D is really hard. So I just want to preface that. Main thing I want you to come out is knowing how to do A and B. As long as you know how to do A and B, then you should be in pretty good shape. First off, h prime of 2. H prime of 2 is the slope of the tangent line at 2. Easiest question in the whole pack of free responses. Slope of the tangent line at 2. Well, here's the tangent line. Here's the slope of the tangent line. Done. That's part A. Part B, they're asking for a prime of 2. So a prime is a product rule here. You're going to see a product rule happen. And then I want to plug in 2. All right, so before I go on to parts C and D, let me make sure that you have those two. So slope of the tangent line is 2/3, then h prime of 2 is 2/3. I went ahead and took my 3 and brought it out front. Plug in 2. We already decided that h prime of 2 was 2/3. So that's how the 2/3 ended up there. H of 2 is 4. I know that from the y-coordinate of the tangent line. So 160. All right, part C. Function h satisfies this equation. Limit as x approaches 2 can be evaluated using L'Hopital's rule. All right, that tells me 2 things. 2 things are happening. One involves f, one involves f prime. First off, since I know that I can use L'Hopital's rule, that tells me that the limit as h approaches 2 is giving an indeterminate form. Most likely 0 over 0. So 0 over 0 is happening inside of this function. So I already know that 2 squared minus 4 is 0. But that means that the bottom is also 0. That 1 minus f of x cubed is also coming out to be 0. All right, so that's thing number 1. Thing number 2 is that L'Hopital's rule can be used. So that means derivative of top and derivative of bottom over derivative of the bottom is giving me my answer. Over derivative of bottom. Here is giving me an answer for L'Hopital's rule. So I can use that to figure out what f prime of 2 is going to be. And I'll show the details of that in just a second. But let me move down to part D. It is known that G is less than or equal to H, and K is in between G and H. Is K continuous at x equals 2? So the idea here is that since G of 2 equals H of 2, and we're continuous, that means that if G of 2 and H of 2 is happening, then let's see. So G is the lowest, so this might be G. This might be H, and at 2, they cross into each other. So K, so this is H, my top function. K is in the middle. If K is in between, then there's nowhere else for K to go but to be also at 4. So K of 2 is also 4. There's nowhere else for it to go. That's a theorem called the Squeeze Theorem. It's what lets us do the limit of sine of x over x. But it's saying these functions, these top and bottom functions, are squeezing in the middle function to leave it nowhere else to go but to the same place that G and H went, since K is always in between the two. All right, here are your details. So here's me explaining that Squeeze theorem. But over on part C, L'Hopital's rule can be used means that the bottom has got to be 0 to get an indeterminate form. So that means that f of 2 had to be 1. And we also knew that the limit is 4. How do we know that the limit ends up being 4? Well, it tells us that we have a continuous function and that these two functions are both 4. So that means the limit also has to be 4. So if the answer here is 4, when I plug in 2 here, the top is 4, so the bottom has to be 1. So here's the bottom. I'm setting it equal to 1. I already know that f of 2 is 1. So negative 3 times 1 squared times f prime of 2 is 1. That's what gives me f prime being negative 1/3. So that one's tricky because it's got a really good working knowledge of L'Hopital's rule, both the conditions required for it and the way that L'Hopital's rule works. You need to know how both of them function. Again, if there's any part of this, hopefully some of this is making more sense to you or clicking or you're catching where you messed up. If there's any part of this that still isn't making sense, come talk to me and we can talk step by step through each of these parts of questions from scratch. But thanks for watching all the way through. Talk to you more soon.